Okay, so here we have piecewise functions, and we just want to check to see if they're continuous or not. So first of all, we should check the actual pieces of the function. Well, these are polynomial pieces. They are continuous, so then we only need to really worry about the points where they join. Okay? And we need to check for discontinuity. So we should really check for discontinuity at x equals 1, and well, just really at x equals 1 between here and here and here and here. Okay, so let's check the limits. Okay, so the limit as x approaches 1 from the negative side. Okay, so that would be this one here. Okay, so I'll just highlight that, of f of x. Okay, so if I plug 1 into here, I'm going to end up with 0. Okay, we see that f of x is equal to 0 at x equals 1, so that's all good, so it checks out. And then we should do the limit from the right hand side. Okay, so the limit from the right hand side, what's going to happen here? So we have the limit as x approaches 1 from the positive side. Okay, we're going to use this one here. We plug in the 1, and again we're going to end up with 0. This is all consistent. Okay, we have zeros all the way around, so we know it's continuous from here to here and to there, so this is a continuous function. Okay, so I'm going to claim that this is continuous. Okay, if I were to graph this, right, this is an upside down parabola. It's going to look like this. A parabola that looks like that. Okay, and then it's going to be the right side up parabola. That's actually just going to be in red here. Okay, we're going to have a point at x equals 1. Well, it's going to be at 0, isn't it? It's going to be at 0 here. Okay, so the graph is going to come up through the vertex, hit there, and then the bottom part of that graph is really just a parabola it's going to look like this, and then like that. So there's a parabola, blue parabola, and the other parabola is going to look like that, and the function is going to be this piece here is going to go like this and then bounce up like that. Taking a look at this piecewise function, okay, we want to check again where the transitions happen. Okay, so first of all, check the graphs. This is a continuous function, continuous, continuous. We don't need to worry about the continuity within the function. We just need to check the continuity of these points that they join. So the limit as x approaches 1 from the negative side is going to be equal to 0. And the limit as x approaches 1 from the positive side is going to be equal to 1. Okay, so when I plug it into here, that's going to be equal to 1. Okay, so this is limits do not match, so it must be discontinuous at x equals 1. So discontinuous. Okay, so then we need to check the other transition point at x equals 3. So at x equals 3, okay, we're going to check the continuity at x equals 3. So limit as x approaches 3 from the negative side. Okay, plug in 3, that's going to be equal to 9. And I'm going to check it from the other side as well. So the limit as x approaches 3 from the positive side of f of x, when I plug in the 3, I'm going to get 6 plus 5. That's equal to 11. And again, because the two limits are not equal, we know that it is discontinuous. At x equals 3. Okay?